Let's quickly review parallel and perpendicular lines. Parallel lines are lines that go on forever side by side and they never touch. So I like to think the Olympics when I have parallel bars. It's two bars that are side by side and they don't touch. They're at the same distance the whole way through. Perpendicular lines are the ones that cross at a 90-degree angle. So it crosses at a corner. All right, so when we are given the equation of two lines, we can figure out if these lines are parallel or if they're perpendicular by looking at the slopes of the lines. Let's start with parallel lines. Two lines are parallel, so again, side by side, forever and ever and ever, they never touch, if they have the same slope. So parallel, since the lines look the same, their slopes are the same. So that means that if you have two parallel lines, if you know the slope of one of them, you know the slope of the other line. It actually goes backwards as well. If you are told that two lines have the same slope, I don't even need to see those lines. I know that those lines are parallel. So let's take a look at an example here. We want to show that this line, y equals negative 2x plus 3, and the line 4x plus 2y equals 0 are parallel. So let's first find the slopes of both lines. This first line is already in our y equals mx plus b format in our slope y-intercept form. So that means that the slope is just going to be the number in front of x, which is negative 2. All right, now let's take a look at the second equation. This equation is not in our slope y-intercept form, so I'm going to rearrange it. I want to solve for my y. So I need to first get rid of this 4x by subtracting both sides by 4x. So the 4x minus 4x, that becomes 0. Then I have a 2y on the left, and then 0 minus 4x is just minus 4x. Finally, I want to get rid of this 2 that's in front of y. Now, if there's a number in front of a variable, they're being multiplied. So to get rid of them, I need to divide. So let's divide both sides by 2. The 2 and the 2 divide out. So I'm just left with a y equals negative 4 divided by 2 is negative 2. So I have a negative 2x. Now, this is in our y equals mx plus b form. It's just that the b is 0. That's why it doesn't look like there's anything there. So to find the slope, I just need to take the number that's in front of our x. So the slope is negative 2. Since these are the same slopes, we know that the lines are parallel. Parallel lines are nice. They look kind of the same, so their slopes are the same. How about perpendicular lines? Remember, perpendicular lines are very opposite looking. They cross each other at a 90-degree angle. So it turns out that because perpendicular lines look so opposite, we know that two lines are perpendicular if their slopes are very opposite. And in math, very opposite, there's two components to it. First, there's the negative component. So if one of the slopes is positive, the other one's going to be negative. And then there's the reciprocal component. Some teachers call this inverse. All it means is that we are going to flip the number. So pretend the number is a fraction and you're going to flip it. That's what negative reciprocal slopes mean, okay? So I'm actually going to jump straight to this wise tip for a second. Negative reciprocal slopes, another way that I like to think about it, is the negative flip of the number. So for example, if we have the number 3 over 5, first of all, that's positive. So if I want to find the negative reciprocal, I need to make it negative, and I need to flip the fraction. So positive 3 over 5 becomes negative 5 over 3. How about if I have whole numbers instead of fractions? Well, if I have the whole number negative 2, I can think of this as negative 2 over 1. In which case, now I can flip it, right? So I need to flip the sign, so a negative becomes a positive. And instead of 2 over 1, it's going to be 1 over 2. So positive 1 over 2 and negative 2 are negative reciprocals of one another. All right, so perpendicular lines have this cool property that if they're perpendicular, their slopes are negative reciprocals of one another. And if I told you that two lines have negative reciprocal slopes, I don't even need to see these lines. I know they're automatically perpendicular. Now let's take a look at an example here. We want to write an equation of a line that is perpendicular to y equals 4 minus 3x. First of all, there are so many answers to this question. There's not just one. Why? Well, if I have the line y equals 4 minus 3x, let's pretend that's our line. How many lines are perpendicular to it? Well, this line is perpendicular to it because it's 90 degrees. This line is perpendicular to it. This line is perpendicular. This line is perpendicular. All these lines have the same slope because they have the same steepness, but they all have different y-intercepts. So we just need to find one of these lines for the answer for this example. All right, so first, this line that is given, we can find the slope from that line. I'm going to rearrange this into our y equals mx plus b form. So I can clearly see that my m is -3 and my b is +4. All right, if my slope is -3 and I have a line that is perpendicular to this line, what do I know about the perpendicular slope? Well, that's going to be the negative reciprocal. So I'm going to write that down with a special notation. I know the slope is -3. So the slope of the line that is perpendicular, I draw this little corner symbol, is going to be the negative reciprocal. So a negative turned into a positive. Instead of 3 or 3/1, I'm going to flip it and make it 1/3. So the slope of the perpendicular line is going to be +1/3. So a line perpendicular to the given line is y equals mx plus b, which is the slope, 1/3 x, plus you can pick whatever number you want here. So I'm going to put a smiley face. Pick your favorite number, put it in. That is a line that is perpendicular to y equals 4 minus 3x.